Section 4.9. Our objective today is I can solve polynomial inequalities. Polynomial inequalities are polynomials that look similar to this. So this is one example of the type of problem that you'd want to solve today. Or here's another one. X squared minus 1 is greater than x plus 5. So those are examples of polynomial inequalities, right? And so if we think about this, we are saying that this side has to be greater than 0. So we're saying that it must be a positive number. And we remember that we can factor that polynomial, and we know that it will factor to x minus 3, x plus 2. And so if I'm multiplying two numbers together and they have to be positive when I multiply them together, either this one is a positive and that one is a positive, or they are both negative. In other words, both numbers have to be the same sign. So in order to solve these, we are going to have to determine where these values have the same sign. And in order to do that, we're going to use number lines. So the key to these is that if we want a times b to be greater than 0, then both a and b are the same sign. If we want a times b to be less than 0, then a and b must be opposite signs. Okay, so we're going to use that idea in order to solve our inequalities. So let's look at an actual example. So example 1. I have y squared minus 3y is less than or equal to 0. So just like with polynomial equations, we want to get 0 on one side by itself and everything else on the other side. Then, just like polynomial equations, the next step is to factor. So first step in factoring is look for common factors. So there's a common factor of y, so we factor that out. Then, just like with polynomial equations, we take each factor, set it equal to 0. Okay, now the process starts to change a little bit. The values that we get, in this case 0 and 3, we call those our critical points. And what we do is we put those critical points on a number line. So here's 0, 1, 2, 3. And what those critical points do is they divide the number line up into sections or intervals. All right? So then we take our two factors. So we have y and we have y minus 3. And we take those two factors and we choose a number from each interval. So in this interval, we have -1, -2, -3, -4. We can choose any number we want. So let's say I choose -2. So I get -2, and I have -2 minus 3, which is -5. So I have a negative times a negative, so this is going to be a positive number. So in this interval, y times y minus 3 gives me a positive number. Then I go to the next interval and I do the same thing. Just pick a number in that interval. So I'm going to pick 1. So I have 1 and I have 1 minus 3. And all I'm doing is replacing y with 1. So that gives me -2. So that gives me a positive times a negative, which gives me a negative value, or a negative product. Then I go to the last interval and I choose a number there. So I'm going to choose 4. So I'm going to put 4 in for y, and 4 minus 3 equals 1. So I have a positive times a positive, which is going to give me a positive value. Okay? Now, if we look at our inequality, we want this to be less than or equal to 0, which means that we want it to be, this side must be negative. So we look at our number line, and the only place where the product of the two numbers is negative is this interval between 0 and 3. Okay? And so then that is our solution. So our solution then for this one is all y such that y is greater than or equal to 0, because we have the equal sign here, so 0 is included, and y is less than or equal to 3. Okay, so the solution to this inequality is the interval between 0 and 3, inclusive. So this is our solution. And this is, and the picture of our solution, the graph, would be 0, 3, closed circle on 0, closed circle on 3, and all values in between. All the values in between 0 and 3 and 0 and 3 will make that inequality true. All right, let's go on to example 2. Y cubed minus 16y is greater than or equal to 0. So step number 1, make sure you have 0 on one side, everything else on the other side. We have that. Step number 2, factor. First step in factoring is look for common factor. There's a common factor of y. Then continue factoring. What's in the parentheses is difference of squares. So we know that that will factor to y plus 4, y minus 4. Okay. Then we look for our critical points, and we do that by setting each factor equal to 0. And solving for y. So now these values 0, -4, and 4 are what we call our critical points. So we plot those on a number line. And we use those to divide the number line up into sections or intervals. Okay? And so on this side, I'd have a -5. In between -4 and 0, I have a -1. In between 0 and 4, I'd have at least a 1. And then after 4, I'd have a 5. And again, I can pick any number in that interval. Then I take every single, every factor. So one factor is y, another factor is y plus 4, and another factor is y minus 4. And then I plug in a number from each interval. So for the first interval, I'm going to put -5 in for y. Okay, and so what I get there is a negative times a negative times a negative. So in this interval, the product of this times this times this is always going to be a negative number. Then I go to the next interval and I do the same thing. -1, and then -1 plus 4 is going to give me a positive 3, and -1 minus 4 is going to give me a -5. So what I have is a negative times a positive times a negative. So that's going to be a positive number. Then I continue, go to the next interval, put a 1 in for y. So I have 1 plus 4, which is 5, and I have 1 minus 4, which is negative 3. So I have a positive times a negative. And so that's going to give me a negative value when I multiply all those three together. Then I go to the last interval and do the same thing. 5 plus 4 is 9, 5 minus 4 is 1. So I have a positive times a positive times a positive. So my answer is going to be a positive number. Now I go back to the original problem, and I want this value to be a number greater than 0. So what numbers are greater than 0? Positive numbers. So I come down here, and everywhere where I end up with a positive value, which is here and here, is my solution. So now I read my graph. So my solution is all y such that this part of the graph says y is greater than negative 4 and less than 0. Was there an equal sign? Yes, so that we would include those. And then this part of the graph, so we write or, y is greater than or equal to 4. So the solution is this interval and all the numbers to the right of 4. So as long as I pick something in from this green area or this green area, the inequality will always be true. Okay? And so again, my number line really should look like this. So I have negative 4 and 0. So it'd be a closed circle, and everything in between. Well, let me just do that in green. And then I have 4, and that also would be a closed circle, and the arrow is going that way. So remember, for any inequality, you're always going to have a number line or a graph to represent your answer. Okay, example 3. Example 3, I have x minus 4 times x plus 2 is less than 0. So I already have 0 on one side. Next step is to factor, but it's already factored. Next step, set each factor equal to 0, and the purpose of doing that is to find what we call our critical points. So in this case, I get critical points of 4 and negative 2. So here's negative 2, 0, here's 4. So negative 2 and 4 are my critical points. So they divide the number line into 3 sections. And now remember that what I do is I pick a number from each one of those sections. So I'm going to pick negative 3 from this one, 0 from this one because that's a really easy one to use, and 5 from that one. Then you take all the factors, which in this case are x minus 4 and x plus 2, and you test to see what happens. So if I put negative 3 in for x, this equals negative 7, and negative 3 in for x in this one, I get negative 1. So I have a negative, I have a negative times a negative. So that's a negative times a negative is always going to be a positive. Now I do the same thing with 0. 0 minus 4 gives me negative 4. 0 plus 2 gives me 2. So I basically have a negative times a positive, and that's always going to be a negative value. and then I check the last region. So I have 5 minus 4 equals 1, and 5 plus 2 equals 7. So I basically have a positive times a positive, so the result is going to be positive. Then I go back, check my original problem. So the original problem says I want this product to be less than 0. So what kind of numbers are less than 0? Negative numbers. So I come back and I look in what region or interval is my answer going to be negative. And again, it's going to be the numbers between -2 and 4. Now notice that in my original inequality there's no equal. So it's going to be the set of all x such that x is greater than -2 and less than 4. But -2 and 4 are not included. My number line solution would look like this. Here's -2, here's 0, here's 4. So it would be an open circle on -2, an open circle on 4, and everything in between. So that would be the solution to that problem. Okay, example 4. I have 36 is less than x squared. Okay, so again, first step is to get a 0 on one side. So I probably would subtract 36 from both sides. So I have 0 is less than x squared minus 36. Or I could write that as x squared minus 36 is greater than 0. This is the way that we're more used to seeing it. So then the next step would be to factor it. Take each factor, set it equal to 0. And so those are our, what we remember we call those our critical points. So here's -6, here's +6, and those points, critical points, divide our number line into 3 sections this time. Pick a number in each section. So I'm going to pick, say, -7, 0 is a real good one here, and +7. Then I take my factors, and then I plug in the number from each section. So -7 plus 6 gives me -1, -7 minus 6 gives me -13. So I have a negative times a negative, so that's going to be a positive value. Then I come to the next region, or interval. 0 plus 6 equals 6. 0 minus 6 equals -6. So I basically have a positive times a negative, and that's going to give me a negative value. And then I go to the last region and plug in a number, any number from that region or interval. So here I'm going to end up with a positive times a positive, which gives me a positive value. Now going back, we go back to where we have the inequality with 0 on one side. So we come back to here, and it says we want this side, we want this side to be greater than 0. So what kinds of numbers are greater than 0? Positive. So I come back and I look for the positive regions or intervals. So it's going to be here and that way forever, and here and that way forever. Okay, so now we have to read our graph. So our solution is all x such that x is less than negative 6, or, because that is the classic picture of an or statement, or x is greater than positive 6. Okay, and our number line again would be, open circle on negative 6 with an arrow going that way, open circle on 6 with an arrow going that way. So that would be our solution there. Okay, and let's look at one more problem. Let's look at y minus 1 times y plus 1 is less than y plus 1. Well, at first glance we would think that that is factored already, but remember that we have to get it set equal to 0. So what we really have to do here is multiply it out, get 0 on one side, and then factor again. So this is going to be y squared minus y plus y minus 1. So this is going to be y squared minus 1. Subtract y from both sides. And subtract 1 from both sides. Okay, so what I have now is y squared minus y minus 2 is less than 0. Now I'm going to factor that. So I need something that multiplies to negative 2 but adds up to negative 1, so it's going to be a minus 2 and a plus 1. Set each factor equal to 0. So I get y equals 2, y equals negative 1. And we see that our critical points then are negative 1 and positive 2. So we use those to divide up the number line into intervals. And then we use our factors. I'm going to choose negative 2. 0 is always a really good one, and 3. So negative 2 minus 2 equals negative 4. Negative 2 plus 1 equals negative 1. So I have a negative times a negative. So that's going to be a positive. I have 0 minus 2 and 0 plus 1. So I have a negative times a positive, which is going to be a negative. And then I have 3 minus 2 and 3 plus 1. So that's going to be a 1 and a 4. So that's a positive times a positive, which is going to be a positive. Now remember, we go back to where we have the inequality with 0 on one side. And this says that I want this side to be a number less than 0. So I want it to be negative. So I come back, look for the negative interval. It's this one. There's no equal involved, so it's all y such that y is greater than negative 1 and y is less than 2. And that's it.